think this is part 4, maybe part 3 of week 8 here. We're covering chapter 8 from the textbook, how to test, debug, and deploy programs. So I know we've covered testing and debugging, and you guys know some of that stuff. And I just don't think we've covered breakpoints and how to actually find the executable file. So really quick, just to cover some of this stuff so you know where it is and how to do it if you ever need to. The objectives obviously are laid out here, being able to test and make a plan for testing. They talk about using Visual Studio and Xcode, but we're going to do this in CodeLite because that's the IDE that we're using. So yeah, the goal of testing really is to find all the bugs in your program before you put it into production. So I think we know that. It's pretty obvious. You want to test and get rid of all the errors you have. So there's usually 3 phases that we have with this. First of all, it's checking the user interface to make sure that it works correctly. Second of all, it's testing the program with valid input. So making sure that if the user uses the program as expected, it works as expected. And then the third phase is testing the program with invalid data. So if you have unexpected user actions or they put a string instead of an int, and making sure that the program can handle those kinds of exceptions. So that's the goal of testing. The goal of debugging is to fix all the errors before the program's put into production. So the 3 types of errors that can occur, and we've talked about these, you have got the compile time errors. So these are what happen in the compiler before you even run the program. They're usually syntax errors or something like that. Then we have runtime errors that they don't violate syntax rules like a divide by 0 or something, but they still cause a crash or an out of memory error or something like that. And then the last one is a logic error. So those are kind of the hardest ones to debug because you don't notice them. They don't show up in the syntax. The program won't crash. It'll just give you weird output because maybe you divided by the wrong variable or something. And a lot of the time it's hard to find them because you don't know that you've done it, right? Cool. So here's some examples of syntax errors. We've covered syntax errors in the past, so I'm going to skip over that. Common syntax errors, we've covered those. Problems with identifiers and with values, doing an equal sign or 2 equal signs. We've covered a lot of that stuff. Okay, so going back to the testing, being able to test your program, you want to test those 3 phases, right? So we've got our miles per gallon program here. If I go back up to it, functions and debugging, CPP, there we go. And I'll just close our other one. So this is our miles per gallon calculator. We've got 2 functions, the display title, calculate MPG, and then we've got our main, which calls those 2 functions. And it's basically just dividing one number by another. Oh, cool. So if we test it with valid data, what that might look like when you're testing it as an expected run is the user actually enters numbers, okay? Now, tested with invalid data, what that means is, say they type 10, but they type it as TEN with letters, with characters or strings. And it has to be able to actually understand what to do in that scenario. So starting to get into the critical test phases. So we want to test it with valid input data and make sure the results are correct, but also with invalid data. So how I might do that, exactly what you might think if I just run this, Control F5. Now I already ran this with 350, so I'm getting 6 miles per gallon. But now if I run it with, what if I write 300? It doesn't like that, right? It just gave me a 0, and then it just exited the program. So maybe we want to be able to catch that error and be like, hey, enter an actual number, not a string. All right, so that's testing with invalid data. So to make testing easier, it's always the best thing if you can come up with a testing plan. So you want to make sure that you're going to list the valid entries that you're going to make and the correct results for them, and then make sure that they're actually correct when you test it. So write it down, use a calculator, and then check to see if it's actually the right number. Then write down the invalid entries you're going to make, and then show what should happen or the limits that the test should allow for. Sometimes you want to make sure you test a wide enough range. So what if the user enters, 1 billion? That's still a number, but it's way too big. Or a negative number or something like that. Or not knowing what the results of each set of entries should be and assuming that the answers are correct because they look correct, right? So what if my numbers are actually dividing? What if 30 divided by 10 gives me like 4, but it should be 3? Something else that you can do, now I won't do this, but something really good for testing for you guys is to see out all of the variables as you go through your program. So we can see here, they go and they print 36 months at a time with an investment and interest rate of $100 at 3%. Over 3 years, that's 36 months. And we can see they loop through and actually print for each month. Month 1, month 2, month 3, and they print the variable future value. Now, through testing, they do this. But then once you actually make sure that that's the right value you're expecting, then on the correct console, you get rid of all of those test prints, and then you just print out the last month, obviously, of 3662. But in order to test that each month is correct, you want to print them out each one by one. And yeah, it can be painstakingly slow or whatever, but it's always a good procedure to test as you go or do test print statements and stuff. And I'm sure you guys did those in Java all the time. Print your variables as you go so you can see them and see what's happening, see when they change, see what's changing them or what they're changing to, and why the errors are occurring. Another way to do this is with breakpoints. And that way you don't have to actually print them all out all at once. You can just view them by hovering your mouse over the variable. So in Visual Studio, a breakpoint looks like this. A debugging session looks like this if you have the debug window open and you can see the variable and the value for what it currently is in the for loop. So we can see I is at number 5, the 5th iteration through the loop. And then we can see the variable as we loop through for the 5th time. Same example in Xcode right there with a breakpoint. So we're going to try to do this with Code Light here. We're going to go and set a breakpoint. You have to right click. So if I want to do, where do I want to put it? Where I'm doing my math here on miles per gallon, and I'm dividing it, right? Let's pretend I want to make an error. Let's say somehow this happened, okay? So if I run my program, before I test it, before I do any breakpoints, before I print anything out, let's say I enter 500 miles and I had 50 gallons. If I take my calculator here, and I type it out, 500 divided by 50 should be 10. But when I get this, I actually get 9.8, which is wrong. And I know it's wrong because I looked at my calculator and I did the testing and I'm like, that's not an expected result. So we want to go through and add a breakpoint. You could print these out each time you go through, or you can do a breakpoint. So if we right click on the line number and add a breakpoint, then what we have to do to actually hit that breakpoint when we build it, when we build it, right up here beside build, we can go to debugger and we can just hit start or continue debugger. So you can hit F5. And then what it's going to do is we can hit build and debug. And what that will do is it will start debugger process and we'll attach it to our program. And if it hits a breakpoint, it will pause. It will take a break. And then what we can actually do is look at our code, look at the values of the variables, and see what's actually happening step by step by step. And you can go line by line by line and actually see how your code's running. So build and debug, and this really helps you visualize what's happening. Okay, so all of the code will happen automatically until it hits a breakpoint. So I'm going to enter my miles driven, 500, 50, and I hit enter, and then boom, it pauses and it hits our breakpoint. Check this out. We can see the little green arrows here, and it's hit our breakpoint on line 11. And we have, a bunch of tools up the top of the toolbar. So we can hit continue, we can hit break or stop debugger, pause, refresh, and then you can step or show the current line or step into. So if there was a function call on line 11 and I want to step into it, it would actually go to that function wherever that function was declared and step into and go even further down and down and down and as far nested as those functions would go. If I want to step over it, then I can step out of a function if I'm stepped into one, and I can step out and then keep on stepping through my program. So if we want to go, I believe we'd want to go next, or we want to go show current line. Okay, so let's go next. So what I want you guys to notice here is we've got our value of gallons, which is 50 that the user entered, and we can actually see for each variable from this line, we can see the value here. The value for miles is 500, and we can see MPG is currently 3.95, okay? Now, we don't know if that's necessarily correct or not, but we can kind of look at this, and then if I hit next, it now goes to line 13. We can see that green arrow moved, and we can go next again. And sometimes you have to hit it a couple times. Next. And now we're here at the end of the bracket. Okay. So I'm just stepping through the program, trying to find where that error is coming from, where I'm getting 9.8. Okay. Another thing you can do in the watches tab here at the bottom in the debugger is you can hit the plus button, and then if you want to watch a certain expression, you can actually type it in there. I think there's a way to also add specific variables you want to keep an eye on, but yes, let me see. I think if I just go, oh, I think I might have just exited it. Whoops. Miles per gallon. Okay. Debugger. Start continue debugger. Now this is kind of a bad example for debugging because it's all happening in one line. And MPG, I mean, maybe I would know if I did the math for myself. Miles per gallon should be, if I get my calculator out, I'll do it on here so you guys can see it. If I get my calculator out as I'm testing this program, okay, and I did 500 miles divided by 50 gallons, and I know that should be 10, okay? But we can see what happens is I'm doing minus 10. So I'm doing 500 minus 10, and then I'm dividing it by 50. I'm getting 9.8, right? Now, if I type this in, 500, 50, here we're getting a value of 3.9 on our miles per gallon, which is actually kind of interesting. And I'm not sure why that's happening. Just trying to step through it here. Next. Round MPG. It could be my brackets. And I'll just hit play. See what we get back. Having a bit of a hard time getting this to actually run here. Debug. Do you guys have much experience debugging? 500, 50. Okay, yeah, let me actually stop this and change. In probably NetBeans, I'm assuming. Go. We're going to run it with an actual expected input this time. 550. Yeah, so this is just giving me a garbage value right now because it's not actually it's not actually been set yet. But if I add a breakpoint here and I go next, it should update it. There we go, to 10. Now it's not 3.9. So it was just creating a garbage double value because it hadn't actually been set yet. We were actually halfway through that line. So if I now add my error back, miles minus 10, what would happen if you're debugging this and you start the debugger is you'd be able to see where that value is going wrong. So we can see as I go next, I'm at 5,500 and then I've got 10 as my miles per gallon. Miles minus 10 divided by gallons, mpg. Next. Oh, I didn't actually compile it, so it's still going to say 10. I just debugged it, but now if I do it, there we go. You have to be careful of that. If you just hit debug, it won't actually build it with the latest builds. So you have to do build and debug if you change anything in here while you're debugging. And then now, if I go through here and it asks me for my numbers, and I go 550, there's that garbage value, 3.9, whatever. As I go into my next step, I can see that it's going to get to 9.8, and we can see that 9.8007 came from this line because it obviously got changed right after that. Now, that's a pretty bad example of debugging, but it helps to know you can put breakpoints in any point in any function, and then you can remove them just by clicking right there beside them and stopping it. So if you want to add a breakpoint at any point, you can go like this, double click, right beside the line number, or just single click actually. And if you debug and you want to step into, say I'm on the calculate underscore mpg function, and I want to step into that function, 550, it's now hit line 30 in my main, but I actually want to step into that function. If I just hit next, it'll just go to line 31, 32, and then print out the answer. But if I want to actually step into that function, which is declared and defined on lines 10 to 14, then I can just make sure I go step into here, and then it will bring me back up to line 10, and then I can go next, next, next. It'll go 11, 12, 13, 14, 15, and then at any point I can hit step out. It'll step out of that function back to line 30. It'll bring me back down to line 30, and then obviously it just finished the program because it printed out the miles per gallon and ended. So it can be a little bit glitchy sometimes with debugging, but it's good for you guys to know how to do it in CodeLight, very similar to NetBeans or Visual Studio if you're used to debugging in that environment. But just wanted to cover that. The one last thing I wanted to show you guys is where to find the executable file for a program that you've made in CodeLight or C++. And then if you actually want to deploy a program, if you're finished it, or if you actually wanted to send it to a buddy for them to have that program. So what we can do, you can see the path here. This is actually different than the path will be for you if you want to find your executable. But a really easy way to do it, to find your deployed program, is to right click on the folder and then hit open containing folder in CodeLight. Then what that does is it'll open up your file explorer on Windows, or if you're on Mac, I'm just going to bring it over from my other monitor here. And what we can do is, because again, we're in the debug version. If you wanted to make a release version, you can make a release version. But because we're in the debug version, we go into the debug folder, and then we'll actually find our exe right here, week 8 functions and debugging exe. If I double click this, it's my program. And there's no debugging or anything like this. That's my program right there, done. And you could take this exe, put it on a USB stick, or upload it to, whatever server you wanted to, if you wanted a friend to download it, and then they could have a program that you created. So if you wanted to make an interest calculator or whatever that runs in the console, that's how you can do it. And you can actually deploy that by making the executable file available to your users. So you can double click it to run it, or you can run it from command prompt. By running it from command prompt, you just cd into the folder, and then you just run the executable file from your command prompt. So that's where your exe files are. Whenever you build it, it updates this exe, and then you've got it right there. So there you go. Now for me, I think because I've got the debug version on and I've got a breakpoint, it's not actually running the cout version here. So if I build project. I could even make it a release version. And we can do build project. What we can now do is go in here and there should be a release folder. And so now we've got our release. And so none of the debug information will be in here. It'll just be our exe, our object code, and we can run it. And there we go. 550. And for some reason, it prints out miles per gallon, but then I don't have a pause. Like I don't have a, I could add like another cout or cin.ignore and it would pause before exiting the program. But because it just prints this ends line and then returns 0, the program exits. So it's going so fast you can't actually see it. But that's how you find your executable. So cool. I think that's all I have for you guys today. I'm going to end the recording here. If there's any questions, we can cover those. There's no labs this week, no homework, no tests. So kind of an easier week as we settle back into the second half of this semester. Hope you guys enjoyed what we covered today. And I'll post these videos on YouTube and you'll be able to find them and the links to them in Blackboard. You can go through the PowerPoints there for your practice. But yeah, no homework, no labs this week. So just enjoy. If you've got other work to do, then you can focus on that. But thanks guys for coming to class and I'll see you guys next week.